Hi guys, Seth Brunson here, Enterprise Systems Engineer and Team Lead at IMPRES Technology Solutions. And today I wanted to take a few minutes to talk to you about a really unique and exciting set of technologies from our friends over at Fiber Mountain. So they do two things really well. First one is they dynamically document your entire network. And the second one is they can basically virtualize the physical layer of your network using software and intelligent patch panels and cables. So let's take a look at how this stuff works. So the first thing I want to show you is the SENSUS Intelligent Patch Panel. So without power, this is just a regular 100% passive patch panel. But when power is applied, we start to see some interesting benefits, like port presence. So we can tell if something's plugged in to any port at any time. And we can tell you exactly how many available ports you have on any given device throughout your network without having to send someone out there to count them by hand. And I can tell you that feature right there is pretty dang helpful, but there's more. So the next one is guided moves, adds, and changes. This one's really cool, you guys. I mean, basically every single port on this patch panel has a little LED light on it that we can manipulate using a GUI or your web browser. So we can change the color of these lights or make them flash on and off based on events or alarms, or you can do it programmatically, or you can do it manually if you want to show someone what to do with that patch panel. So I'll show you some examples of how we're using that in a few minutes, but this is a pretty cool feature. We also have auditing of all insertions and removals. So basically it just keeps track of everything you do. And end-to-end cable visibility. So we can tell you the fastest route from one device to another, and all sorts of interesting things start to happen with this. This unit is a 2-rack-U device with 2 modular patching modules and a central management console. So with this one, we have 192 LC fibers in the front and 16 MPOs in the rear. These modules are available in either single or multi-mode with various configurations of MPO and LCs, and the MPO densities can be 8, 12, or 24 fibers. This central console right here provides an LCD touchscreen for management. So we've got an SFP test port for continuity and bit error testing, a USB port for third-party integrations, and a console port for the initial configuration. Another thing that's really cool with this panel is it has this little NFC-enabled sensor. Basically, this is an RFID for point-to-point, and we can just wave our cable in front of it, and it'll show us all of the pertinent info about that cable, like the length of the cable, the serial number, its polarity, and any custom information on the cable that you want to store. So that's how we add intelligence to the patch panel. But to make all of this work, we also need intelligent fiber cables. And actually all the work is done by these little clips that we add to the fiber cable. So the cables themselves are not necessarily different. These little clips can be added to your existing fiber cables, or you can just buy these super premium fiber cables from Fiber Mountain that include the clips automatically. But they're really easy to just snap on, and some people don't want to replace thousands and thousands of cables. So this starts to give me some pretty interesting features. So I can do things like record and retain any data that's relevant to each of these cables. I can also do things like tag the clips to have different levels of security classifications. So for example, you could enforce security on each of these clips and therefore the cables so that people can't use them to access things that they shouldn't be. And these clips are also what enable us to dynamically document your entire network. So that's how we add intelligence to the patch panels and to the cables. Let's take a look at what kind of features we get as a result. So a long time ago, when you needed directions from one place to another, you'd have to go to your gas station or something and buy a paper map and bring that with you, and that's how you got around. Then after that, we had the internet, so you got tools like MapQuest. So you could put in your 2 different locations and print out the semi-custom map, and it was a little bit better than an old-fashioned paper map. Then we had things like Garmin, where you put this device in your car and it's actually a GPS, so it can give you somewhat realistic directions from point A to point B, but it's still clunky and you have to download the updates manually. Now, everybody carries a supercomputer in their pocket at all times, and this thing can give you point-to-point directions from anywhere in the world to anywhere else in any language, and it can even read it out for you. And it updates itself automatically. So this is the same thing that Fiber Mountain has done for Layer 1 by providing automated documentation of your network. And we do this by adding intelligence to the physical layer. So while everyone else is still using a spreadsheet to document their physical network, and believe me, most of our customers are still doing things exactly like this. Fiber Mountain lets you dynamically figure out exactly what is connected to what. So this gives us accurate documentation and topologies 100% of the time. It can also alert you to events using alarms. So you get immediate alerts of unplanned changes, physical security breaches, cabling errors, and you get these alerts when they happen, rather than after they've already caused damage. And these alarm notifications can include a description of the problem, the severity, time of occurrence, the device location, the port, even what type of fiber they're using. We also provide a built-in audit trail. So it's going to improve your awareness. I mean, wouldn't it be nice if you had an audit of every single thing that anyone had touched or changed on your network? The answer is yes. Obviously, this is going to help keep you secure, but also compliant with regulations. So the audit trail provides another layer of visibility by preserving all events that occur in a data center in a record that can't be altered or deleted by anyone. This audit trail is recorded from the very first time that we install it, so you have a detailed history of everything that's ever happened on your network. And of course, you can export it for analysis or presentation or whatever you want. Another huge challenge our customers face is data center co-location. So we've got people with data centers all over the world, and it can be a nightmare trying to manage those things remotely. How do you guide someone to do a patch remotely? How do you verify that they did the patch correctly? What if there are no people available when you need them? Doing these cable moves, adds, and changes in a co-located data center usually requires skilled technicians who are familiar with that location, and that can be expensive. These people require detailed and precise work orders, and when they arrive on site, they have to find the right cable, locate the right patch panel, and then patch it to the correct port. This process is time-consuming and error-prone, normally because this person is A, not familiar with your co-location, B, not familiar with your patching system, and they usually have to rely on written instructions for the work order. So it usually looks something a little bit like this. I send my technician across town with a piece of paper explaining what I want him to do. You know, something like look for the 4th rack on the left, try to find the 5th switch down from the top, and then locate the 12th port over from the left and plug your cable in. And hopefully he gets everything right and it works, but we won't know until he gets back to the data center to test it out. That sounds pretty stupid, right? And the chance for human error is massive. But this is literally how most of our customers are functioning right now. With our intelligent panels and cables, the process would look a little bit more like this. I send a technician across town to the data center, and when he walks in, I push a button from my desk back in the NOC that makes every single light on that panel flash on and off. So the guy doesn't have to search around, he just walks to the panel that's flashing like a giant neon street sign. And when he gets there, I push another button and the individual ports that I want him to interact with light up. So he takes one end of the cable and plugs it into one port, and the other end into the other flashing port, and then I can instantly see from my laptop back in the main data center that he did the job correctly. Let's say I'm not available to turn the flashy lights on and off for my technician. We can also just program the work order into the system remotely. So when he gets to the flashing panel, he waves the cable in front of the NFC reader and it'll show him the work order right on this LCD screen. And it'll automatically flash the ports that he needs to interact with. This makes it almost idiot-proof. And after the patch is complete, the guys back in the NOC can remotely check the work in real time to see if the patch was done correctly. So this lets the NOC provide instant feedback to that remote person. In this example, the remote employee did not need prior knowledge of the colocation or the patching system. Instead, we used software to guide them through the entire work order. This not only reduces the time for the patch, but also minimizes the chance of human error causing an incorrect patch. So that's how the patch panels work. But we've also got another product that makes this whole idea pretty much limitless in its capabilities, and that's the optical path exchange. Let's take a look. So this is the part that lets us virtualize your layer 1. This is basically a switch with programmable light path connections. So what that means is it allows us to dynamically reconfigure the paths in your network using software. In other words, once this thing's installed, no human hands are needed to move your connections around. So you can program and reprogram as many times as you want without physically touching any cables or ports. Obviously, this is going to seriously cut back on wear and tear, which is a much bigger problem than you might think it is, because you're not plugging in and unplugging and moving this stuff around all day long. We can prevent data from going the wrong direction. So think about nipper, sipper, high and low network, stuff like that. Some people use physically keyed ports to make sure that only certain cables can connect to certain ports. That's a real pain in the butt, besides just being expensive. We can do this using custom labels in the software. So if someone does it wrong, I can send an alert and we don't pass the light. So we stop the connection right there. There's no data passing anywhere. Another phrase for that is zero trust. So we can program these things so no light passes through any of your switches until someone specifically allows that connection. But like I said, you're really only limited by your own creativity when it comes to what you can do with this thing. So this facilitates a fully lights out data center. That means I can dynamically move my connections around. I can copy connections. So I can take a connection in and I can multicast it out to hundreds of other destinations using software rather than manually cabling everything up. I can dynamically monitor and tap all of my connections at any time without needing a physical tap device. And you can even change the polarity of your connections. So if you wanted to go from 10 gig to 40 gig, you can do that programmatically. I mentioned that we can do dynamic tapping. Here's a quick look at how that works. So tapping is something we all use for troubleshooting, compliance, and security to give us visibility into ongoing network conversations. Traditionally, to tap something, we would capture network traffic and send a copy of that to some type of monitoring device. In a perfect world, we'd be able to tap any connection at any time, but up until recently, the only way to do this would be to set up an entire parallel network, which is just going to be ridiculously expensive and difficult to manage. Most people instead use a limited number of taps, and then they just manually move them around when a new port needs to be monitored. For example, today I might need to tap the server in this rack, and then tomorrow I might need to tap some routers and things in the second rack, and then maybe next week I have to tap the core switches over here in this rack. Traditionally, to tap these, we would need hardware or agents or port mirroring for each device. The OPX, or optical path exchange, allows us to regenerate the optical signals when it forms the cross connection, and it's all centrally managed. So this allows us to multicast the regenerated signal to up to 160 ports on one OPX with no need for any additional hardware or software. So this gets you some pretty obvious benefits, like every device in connection is tap ready by default. All taps are passive, so we're not interfering with the light or slowing anything down. All of our taps are auditable, and all connections are automatically documented. So clearly this is a much smarter and efficient way to monitor and tap your network. So we talked earlier about data center co-location and guiding someone to do a patch for you remotely. But What if there are no remote employees available? This is where the OPX really shines. So OPX is different from a patch panel because any signal received by the OPX from one cable can be regenerated and transmitted dynamically through any other cable connected to this device. And we control all of this using software. So you can remotely change connections without needing to dispatch a technician to physically unplug and reinsert the connectors. And like I mentioned, one signal can also be transmitted to multiple outputs for either monitoring or broadcast applications. So think of an old-fashioned telephone switchboard, but instead of the operators manually doing the switching, the switchboard is now controlled by software. So here's an example. You've got one rack in a remote location. We include an OPX and a SENSUS patch panel, and then we connect everything together. So now you can change any of these connections from anywhere in the world with network access and a browser. So there's no need to send in a technician to recable anything. We could even pre-wire an entire rack or even an entire data center without needing to know where things will eventually be plugged in. Then we can dynamically move those connections around later when we know where they need to go. So this is going to improve your service request time, it's going to minimize human error, and your cross connects can be guided or completely automated. And these work orders are now going to be done in seconds rather than weeks. And most importantly, nobody else is doing anything like this. This is a completely unique technology, and I think you can see why it's valuable and why we're so excited about it. So if this is something that you're interested in learning more about, let's start a conversation. Please reach out to us. You can hit the Contact Us button on our website, or you can email us at sales@impres technology.com. Thanks for your time and have a wonderful day.